Right now, you're probably touching a piece of glass. You tap it, swipe it, zoom in and out without thinking, and somehow, it understands you perfectly. But here's the strange part. That screen isn't a button. It doesn't move. It doesn't click. So how does a solid, lifeless surface know exactly where your finger is? Every single time. It feels like magic. But the truth is even more surprising, because every time you touch your screen, you're not pressing anything. You're actually interfering with an invisible electrical field, using nothing more than the natural conductivity of your own body. The touchscreens might feel like one of the most modern inventions in the world, something that belongs entirely to the smartphone era. But the core idea behind them is much older than most people think. To understand it, you have to go back to 1965, long before smartphones, before personal computers, even before humans walked on the moon. A British engineer named Ian Johnson was working on a very different problem: air traffic control. Controllers needed a faster, more intuitive way to interact with radar screens. Buttons and switches were too slow. They needed something direct, something they could simply touch. So Johnson came up with a radical idea. What if the screen itself could detect your finger? His solution was surprisingly simple, but groundbreaking. He coated a glass surface with a thin conductive layer, creating the first capacitive touchscreen in history. It wasn't perfect. It could only detect one touch at a time. It was bulky, experimental, and far from consumer-ready. But the core principle? Exactly the same as the device in your hand right now. The foundation of every modern smartphone was already there. And it all works because of something unexpected. Not the screen, not the software, but you. Not all touchscreens work the same way. In fact, there are two completely different systems. And understanding them changes how you see every screen you use. The first type is called resistive. This is the older technology, still used in things like ATMs, supermarket checkouts, or older handheld devices. It works in a very simple way. There are two thin, flexible layers inside the screen. When you press down hard enough, those layers physically touch each other, and that contact sends a signal. It's basically a mechanical button, hidden under a flat surface. That's why resistive screens respond to anything. Your finger, a pen, even a glove. But they require pressure. Your smartphone is completely different. It uses capacitive touch. And here's the key difference. It doesn't need pressure at all, because it's not detecting force, it's detecting electricity. Your body naturally carries a small electrical charge. You're made mostly of water and salt, which makes you a surprisingly good conductor. So when your finger gets close to the screen, something invisible happens. And that's where the real magic begins. Beneath the glass of your screen, there's something you can't see. A network. An invisible grid made of microscopic wires spread across the entire surface. And every single one of those wires is carrying a tiny electrical charge. But here's the crazy part. They're completely transparent. These wires are made from a special material called indium tin oxide, a rare metal alloy that can conduct electricity while still letting light pass through. That's why your screen looks perfectly clear, even though it's full of circuitry. Together, this grid creates a delicate electrostatic field across the display. Stable, balanced, constant, until you touch it. The moment your finger gets close, you disrupt that balance. Because your body is conductive, it pulls a tiny amount of electrical charge away from the screen. Not enough for you to feel, but enough for the system to notice. In that instant, the grid detects a drop in voltage at a very precise point. And that point, that's your touch. You're not pressing the screen, you're stealing electricity from it, and your phone is watching exactly where it happens. So your finger disturbs the electrical field, but how does your phone turn that into something precise? How does it know exactly where you touched? The answer lies in coordinates. That invisible grid beneath your screen isn't random. It's organized into rows and columns, like a map. Every intersection represents a specific point on the display. When your finger pulls away a tiny bit of electrical charge, it doesn't affect the whole screen. It affects one exact location. Sensors around the edges of the screen constantly monitor the electrical state of this grid. The moment they detect a drop in voltage, they pinpoint the exact intersection where it happened, an X coordinate, and a Y coordinate. That location is instantly sent to the phone's processor, and all of this happens in less than a millisecond. From there, the software takes over. A quick tap becomes a command. A continuous movement becomes a swipe. 2 points moving apart become a zoom. So every gesture you make is just a series of tiny electrical disruptions mapped in real time. You're not pressing buttons, you're communicating through electricity. So the next time you tap your screen, remember this. You're not pressing anything. You're not pushing a button. You're completing a circuit. Every touch, every swipe, every gesture is just your body interacting with an invisible electrical field, stealing a tiny amount of charge and telling your device exactly where you are. A piece of glass that can feel you, not through pressure, not through movement, but through electricity. And the most surprising part? This isn't new. It's a technology born decades ago, refined, perfected, and now sitting quietly in your pocket, responding to you hundreds of times a day, all without you ever noticing. Thank you for watching. If this changed the way you see your screen, don't forget to like, share, and subscribe for more hidden science behind everyday things.